Hi everyone, Dylan here from Autodesk. In this video, we're going to look at hole recognition and how it can be used to automate drilling in both primary and multi-axis machining. We'll investigate how templates and the tool library can be used alongside hole recognition to rapidly decrease the programming time of what can traditionally be a long process. Here we have a component which has nearly 200 holes. As with many components, the holes are organised into various groups, with each group designed to cater for different uses. Some are tapped, some are H7 fits, some are clearance fits, and so on. One way to tackle this in Fusion 360 would be to manually select the holes we want, choose a tool from our library, and choose the appropriate settings and then apply the parameters. But when we're dealing with a lot of holes, this can become a tedious process. So to speed up this process, we can use hole recognition to automate some of these steps, to detect holes in both our primary axes and holes in other axes, in as few clicks as possible to achieve the results we want. Hole recognition can be as easy as selecting it, choosing our hole signatures and selecting OK. Whilst this is a viable option, to give us toolpaths for all of our holes, we're going to spend a little bit more time going through all of the options to see how we can set it up for optimum results. The first step in the workflow is to identify the tools needed to create the holes. For instance, to create an M6 tapped hole, we need a 5mm drill and an M6 tap. We can either create our own tools, use our personal libraries, import third-party libraries, or we can use the Fusion 360 sample libraries. Fusion 360 sample libraries contain hundreds of different imperial and metric tools for free. For this example, we'll choose the third option and import a tool library. Once the tools are imported, we can use these for our hole recognition, completing this stage of the workflow. Next, we'll look at hole templates and what role they play in hole recognition. We have what we know as hole signatures. Hole signatures are the geometry which Fusion recognizes. These are the basic 3D shapes like cones, cylinders, and flats, which make up different types of holes. One example of this would be two cylinders connected, the one at the top being larger than the one at the bottom, connected by flat geometry. This would tell Fusion the signature is a counterbore. Hole templates are the toolpaths needed to create that specific signature. Going back to the counterbore example, we may need a spot drill, a deep drill, and finally a 2D bore operation, all in sequence to create this geometry. For the more conventional hole signatures in this part, like a blind tapped hole, I already have a hole template because I've machined this type of hole before using hole recognition. So you can see I already have templates for the tapped holes, the counterbore clearance holes, the reamed blind holes, and the reamed through holes. I just need to create the template for the counterbore reamed hole, as this isn't a hole signature I've came across before. To create the hole template, I want to create my 4 operations here which I've made manually. These 4 operations are spot drilling, reaming, and a 2D bore operation, as these are the operations necessary to create this hole signature. To create the template, select the operations, right-click, and store as hole template. I will name the hole template accordingly, then either save it in a local library or a cloud library. We also have the option to import templates. We simply go into the templates library, import, then select the template we want to bring into Fusion 360. Now we've done all the necessary pre-work. We can click on the hole recognition command and we'll get this dialog. What we see here in the first tab is hole groups. These are the hole signatures which have been identified on our primary axis. You can see hole recognition has detected 6 hole groups. All of the holes on this plane have been identified. We now need to determine the action. This is where our hole templates from earlier come into play. We have our pre-made templates which are automatically defined within Fusion 360. Then we have our custom templates. Fusion 360 will intelligently figure out which holes require which template from the geometry. If Fusion 360 doesn't choose correctly, it's very simple for us to expand the drop-down list and pick which hole template is correct for this hole. Once we've done this, we move into the second tab, which allows us to pick the tool library in which we want to choose our tools from. We can use any of our personal libraries. We can use the sample tools which come pre-made with Fusion 360 or a library we've imported. In this case, I already have the machines tool library which I imported earlier, so I'm going to have this selected and nothing else. This will ensure when Fusion 360 picks the tools for the drilling toolpaths, it's only using the tools which we want and already have set up inside of this library, eliminating the need for more work in creating tools later on. In the final tab, there's a few more options we can define to tweak and optimize hole recognition. The first one we see is limit to the setup plane. This allows hole recognition to identify holes which aren't on the primary axis. This allows us to do multi-axis drilling. If we untick this option, then go back to hole groups, you'll see more hole signatures are available to us. It's now identified all the holes in the component, regardless of what axis they live on. Inevitably, we'll have certain constraints on our machine, such as a machine table which only rotates a certain amount. We can limit hole recognition by angle, with the minimum and maximum angle. This can be a very powerful tool for selecting the hole signatures you want to machine. For example, I could change my minimum angle to 1 degree, ignoring all the holes which are on the primary axis and machining all the hole signatures which aren't on the primary axis. We also have the option to find by diameter. Here we can set a maximum diameter size if there's certain holes we don't want hole recognition to pick up. For example, if we had a 100mm bore in our part, the chances are we probably want to machine this bore another way. In this case, hole recognition will ignore it. We have two options to optimize hole recognition. The first is minimize tool changes. If the same tool can be used on two different groups, these groups will be output consecutively to reduce the number of tool changes needed. Group by size means if a hole requires multiple operations, all the operations will be grouped together. Finally, we have use fewest spot drills possible. With this option ticked, hole recognition will use as few spot drills as it can on the spot drilling operations, saving unnecessary tool changes. And that's how we can use hole recognition in conjunction with the tool library and hole templates to automate drilling in the primary axis and multi-axis. I hope everyone enjoyed the video. Thanks for watching.